presentation that we have today to talk about is on turbidity barriers. So we'll jump right into this. So I'll give a brief introduction of turbidity barriers, answer some of the questions, what are they and why we use them. Then we'll dive into some of the different types of barriers that are currently available in the marketplace, which include your standard OPSS type barrier, type 1, type 2, type 3, 4. We'll have a look at some of the accessories, such as reefing lines, some of the custom hardware. We'll take a look at some of the important aspects of anchoring and, of course, installation. So environmental regulations require that when silts are disrupted on site, they need to be contained. We find that most construction projects that are out for tender have a section which identify the silt and sediment control and products such as turbidity barriers. Essentially, projects around or over a body with the potential of stirring up sediment require a silt curtain or turbidity barrier. Turbidity barrier, when incorrectly installed and selected, reduce the chance of an environmental spill. And it's important to emphasize that it has to be the right barrier, it has to be installed correctly, and it also has to be inspected periodically. It's not a set it and forget it type solution. Why we use these turbidity barriers? Because silts can often become destructive to spawning areas, food sources, and habitat, direct toxicity to wildlife, lake degradation, siltation of navigable channels, impacts of commercial fisheries, reduction of water storage capabilities, and increased flood hazards, increase of water treatment costs, and decreased capacity of conveyance facilities. The picture on the top right-hand side is a project that we completed a few years back, Block 14 Pro-Big, and it's an installation of a Type 2 DOT turbidity barrier holding back the sediments for that project. Turbidity curtains are best managed products, and they're designed to restrict the flow of sediment-laden water from the workspace. If you look at the picture on the right-hand side, the barrier is installed in an arc-type configuration. The workspace just adjacent to the shoreline is generating the silt, and the containment area within inside the curtain is providing the sufficient retention time for the sediments to settle out. And that's really the goal of these barriers, is to provide a containment area and sufficient time that the sediment will settle out. Different types of sediment, different particle sizes will settle at different rates. For example, coarse clay will take up to 24 hours to settle within inside of the containment area, in comparison to, say, a medium sand, which almost settles right away. So understanding the type of sediment that you're dealing with on site will help you identify the area, the size of containment required, and the proper installation of these barriers. The picture on the bottom right-hand corner here is a project that we did a few years back in the Gaspé Peninsula, Quebec. And as you can see, the barrier is doing a really effective job of sediment containment within that area there. And that's ideally the goal that we're looking for here. So the basic turbidity barrier consists of a top flotation material and either a pervious or impervious body. They float vertically. Thank you very much, Matt. And then at the bottom they'll have a chain pocket, and that's effectively acting as ballast to hold the curtain vertically. There's various types of barriers available depending on what the applications are. Fortunately, a number of these barriers are kept in stock within about 2 hours from here. We also have a local distribution available that can provide ready access to these materials. The stock barriers have a standard length of about 15 meters long and depths from 2, 3, and 4 meters deep. So those are more or less the standard sizes. Beyond that, they will be custom in nature and certainly available and possible to supply. There's a variety of different types of materials that the barriers can be manufactured from, and those include products such as RPE, or reinforced polyethylene, PVC, or for longer-term permanent applications, we use a material called XR5, and these are applications that are in service for over 5 years. So the type of material that you're using in your barrier will determine how long this barrier is going to be in service for. first step to identifying the proper barrier for the application is to do a thorough assessment. Key points that we're looking at understanding in the application have to do with duration of service. You know, how long do we want this curtain to last? Ideally, it's a temporary application, so we want it to be in place for as long as the construction project or shortly after, then it's going to be removed. Winter installation. These curtains are also installed during winter months. Cuts are made through the ice, the barriers drop down vertically and installed in place. So understanding the time of year when these are going to be installed is an important step of determining the right barrier. What's the water body type like? We're talking about rivers, lakes, ponds, navigable water. These are all considerations. Often in navigable water, we need to make sure that boaters in the area, you know, at nighttime when they're traveling through, they don't impact these curtains. So there's various accessories such as lights, markers, buoys that we can add. The length of the curtain is also very important. The water depth, and if there's any fluctuation. The Gaspé project was in a tidal area, so every day that curtain would rise and lower almost to its full extent. So understanding what those conditions are will help us make a better suggestion on the right product. Water velocity, so your flow rates. Wind wave action. Is this in an open lake, for example, Lake Simcoe, Lake Ontario, where it has very little protection, or is it in a protected pond? Particle size, we talked about that already. And then what type of anchorage are we looking at? And what does that bottom consist of? Is it hard, rock, shale, where it's going to have a difficult time securing anchorage, or is it a clay, silty material where an anchor will hold quite well? And then the last one is what type of containment are we looking at? We have some projects where there's zero tolerance for leakage. I'll share an example of that in just a minute, where 0 NTU was the goal. Some cases, a little bit of sediment to sneak through is completely acceptable. The picture on the right is an example of one of Layfield's project assessment forms. This is typically what we do to look at these different projects. So proper installation is also really important in how these curtains are hung. One of the regular questions that we get is, should the curtain extend vertically all the way to the bottom? The answer to that is no. Our goal is to keep about 12 inches, 300 millimeters from the bottom of the water body to the ballast. So the idea is for that curtain to be able to float back and forth. The issue with it, if it is sitting on the bottom, is silt can build up on that, or if you get a heavy wind or a wave event, that curtain will actually drag on both sides. And then we get the phone call saying, there's more sediment now than there was before when the curtain was installed. Why is that? This is often a good reason for that. And as we know, all water bodies vary in depth. There's furling lines, which are essentially ropes which extend from the bottom all the way through the top float, and allows us to cinch that curtain up just enough off the bottom so it doesn't disturb the sediment. The picture on the right-hand side kind of illustrates a typical anchoring configuration. It consists of the Danforth-style anchor, or in some cases, concrete blocks work quite well. That leads directly to a floating ball, and then there's a bridle line. And so the idea is for the curtain to freely move back and forth with those bridle lines or those spring lines to float in place. The next few illustrations here illustrate very common installations and configurations of these curtains, starting with figure 1 in an application where there's very little flow rate, so the curtain itself can hold its position quite well, really without any assistance from any anchors. Figure 2 is more representative of a tidal type effect, where you're going to have that constant flow in and out of that contained zone. So we need to be really careful with the placement of anchors to hold that position in both directions. Figure 3 is applications up to 3 feet per second, so a fairly significant flow rate, positioning the anchors on the downstream side of the curtain. And then you've got figure 4, an island or a submerged area that you're trying to isolate. Again, using those anchors to maintain the shape for your curtain and to do an effective job. And then same with figure number 5, that flow rate positioning, keeping the one side of the curtain open and containing the sediment on the top side of the containment. not effective. The curtain can many times be overpowered by the stream, and the sediment will just be pushed through and carried further on downstream. So they're not designed to be moved, to be installed across a water body. And then just to repeat, settling the curtain directly on the bottom, it does leave a chance for siltation to take place where the sediment is sitting directly on the curtain. And over time, if you get enough sediment, that will actually pull the float underneath the water. So the different types of turbidity curtains, as I mentioned, there's a standard, which is your OPSS spec, type 1, 2, 3, and 4. Let's have a closer look at each of these. So the type 1 is typically what we see most often in the tender documents, OPSS 805 specification. Really, this curtain is designed for really slow, up to 0.15 meters per second, really no flow at all. And I do have to say, we see this often specified in applications where we need something a lot more robust, a lot more heavier duty to do the function. It has a woven geotextile body, as Matt is holding up here, different standard depths that are available, and then it's connected together in series using a series of snap hooks and quick links to create the continuous connection. The next version, slightly more robust, is designed for flows up to 0.13 meters per second. This still meets the OPSS specification, but it has an additional heavier flow material, and then it also has the aircraft cable and the hooks on the top, really to create a more robust, stronger duty type applications. Suitable for depths up to 6 meters, and as short as 0.6 meters in depth. Again, connections can be with the quick links and the zip ties from one curtain connection to another to create a fairly continuous, fairly tight type of containment there. Didn't advance my slides, I'm advancing here. My apologies for that. That should help a little bit more. Good thing I've got that here system. Thank you. So the Type 2 turbidity curtain is probably one of the more common barriers that we see being used in these types of applications. Good for flows up to 0.7 meters, and depths up to 9 meters are possible with this curtain. And the Type 2 curtain has a heavy duty fabric, heavy duty material, using a 22-ounce PVC material. As you can see, it is so much heavier duty to assist us to demonstrate that. But you'll notice the cables on the bottom, the wear points on the bottom corners and the top. It's really a far more robust and heavier duty type applications. And the fabric choice for the skirt is either permeable or impermeable. It is possible for us to make those two different options depending on the application. There are customizable heavier duty versions with increased hardware depending on the application. So higher stress, higher flow applications will require some additional support, additional hardware, and those are all possible additions to these curtains. And then the second last curtain that I'm going to talk about here, a little bit to do with the Type 3 curtain. These are typically used in higher flow applications, tidal applications. It does have a fabric permeable body in most cases, and it allows the water to be able to move in and out. There's also the impermeable version as well is available, and we can install these in depths up to 30 meters deep. So these are considerable curtains, really heavy duty. They provide a lot of heavy lifting for these types of installations. And then the fourth version of curtain that is available is what we call a Type 4. Now this one here is really the heaviest duty out of all the applications. We talked about the goal of no turbidity sneaking through. This curtain would be certainly suitable for that application. Enhancements such as Velcro at the different seams to make that seal connection more than just the zip tie or the cable ties in the other versions are possible. It also has an additional feature which is kind of interesting to point out here. This is the chain ballast located halfway down the curtain. It also has an additional skirt inspection to make sure that the curtain is not being overpowered. This is actually a picture with BC Hydro of one of the Type 4s in place. They've actually configured it with a double barrier type setup, so they actually have 2 sets of Type 4 curtains in this application, and they've created a walking surface between the 2 curtains. As you can see here with this hydroelectric facility here, there was very little tolerance for any type of sediment to escape out, and that's not a Photoshop photo. I mean, that's exactly what they were dealing with there on site. They had a team of divers. They actually did a dye test in that installation as well before they put it into service to make sure that there was absolutely no leakage at all. So if you want the ultimate gold standard, this is the type of product that you should be looking at. Okay. Some of the different options, as I mentioned earlier, reefing lines are very popular, and that allows you to be able to hoist up and down the curtain to allow it to contour to the bottom as best we can. Additional reefing lines are possible, certainly customizable item. And in some cases, we can actually taper the curtain, so it'll actually contour to the depth, starting from, say, the shoreline, shallower type curtain, and then gradually increase the depth according to the installation. Okay, looking at some of the different anchoring that we talked about a little bit earlier here. In this case here, using the Danforth style anchor with the chain, rope to the ball, and then you've got your floating barrier sitting just off the bottom. And then again, in this type of configuration here, you've got the contained area in the middle. You've got a series of barriers around with 2 anchors on each curtain. Okay, so typical installation starts with the curtains being bunched up, connected to each other in series on the shoreline. Then they're pulled out in one continuous row. It kind of looks like a links of sausages, so to speak. Once you have the curtain in place, you're going to anchor it off to the shoreline, and then you go around to the furling lines, cut them so that the curtain just drops neatly in place. It's a fairly straightforward process. Always happy to help the contractors out in terms of execution of these installations if they need additional assistance. Certainly, we do that often. These are just some different pictures here, last few slides of the presentation, looking at some of the installations. This is a project in just near Cambridge, Ontario here. This is a land development project, potential to develop a lot of silt and sediment into this water body here. So the installer deployed a series of the OPSS type specs across in one continuous link, and it does an effective job at containing silt and sediment. Not a lot of anchorage required in that installation because it's a fairly well protected water body. This one here, up in Rouyn-Noranda Tech Resources, the particular owner had this type of an issue where their water pond was full of turbid water. So we worked with the design engineer to create a series of curtains that divided that pond into 3 different zones. And the end result is a series of zones that allow the sediment to settle out so they can easily draw from more cleaner water and use within the operation. A little closer to home here, Lock 14, Trent Severn Waterway. This is part of the rehabilitation project for the dam system there. Temporary rock dam was installed here on the layfields and permeable membranes, and deployment of the curtain to prevent that silty water from making its way down. And that's kind of a bird's eye view of what the installation looks like. Doing an effective job at keeping that contained. Picture or the project in Bonaventure, Gaspé Peninsula, staging area, inflating all the floats, installers in the water. They're fortunate to be shallow enough. They were able to get in there at low tide, make the connections properly, and the end result is a very effective installation. And as I mentioned, that in being in the tidal zone is certainly allowing the curtain to rise and lower. This one here at Nicoego up in Nunavut, they were able to borrow their helicopter to use the ballast rocks instead of anchors, dropping them in place. These curtains were in excess of 50 feet. So they were massive curtains to be in place.
questions for Justin?